All right, geometry students, today we are going to be talking about ASA and AAS triangle congruence. And what I mean by that is we use A for angles, S for sides, and so this would be angle, side, angle, and angle, angle, side, triangle congruence. We should be able to determine whether a pair of triangles are congruent using angle, side, angle, and angle, angle, side congruence theorems, and we're going to talk about these two theorems as well as prove statements about triangles using these theorems. Make sure you're following along with our filled in notes and let's get started. The first theorem we're talking about is the angle side angle or ASA congruence theorem. And basically what this says is that if two angles and the included side of one triangle are congruent to two angles and an included side of another triangle, then the two angles are congruent. The reason why we can use this, for lack of a better word, shortcut, the reason why we could use this shortcut is because you can see that by making the two adjacent angles and the included side congruent, that means we can't change anything about the third angle or the other sides. That means there's exactly one set of sides and angles for this triangle for them to be congruent to each other. Let's break down this angle side angle situation for this diagram. So in this diagram, basically we're saying if angle A is congruent to angle D, so you can see the arc marks here, single arc marks, and if side AB is congruent to side DE in the other triangle, again labeling with tick marks for congruent sides, and if angle B is congruent to angle E, double tick arc marks here. If all of the following is true, then we can say with a congruency statement that triangle ABC is congruent to triangle DEF. Again, make sure that when you're writing congruent statements that all of your matching angles and sides line up in that statement. So let's try out a proof. I'm going to work on number 2 in our guided notes. So we are given that segment JK is parallel to segment LM. I'm going to go ahead and mark that on my diagram right now. Here's JK parallel to LM. And I'm also given that segment JL is parallel to segment KM. So I already used single parallel line markers. Let's use double for the other set of parallel lines. So JL is parallel to KM. So this is the information we know, and we're asked to prove that triangle JKL is congruent to triangle MLK. So this is going to be a little tricky just because we don't have any congruent sides or angles yet. So our first statement, let's just start with our given information. These two pairs of sides are parallel. That is given as our reason. Then it looks like we're going to prove that some angles are congruent. And if we think back to one of our previous topics, when we talk about parallel lines and what pairs of parallel lines cut by a transversal mean for angles and their measures, we can see the relationships with these parallel lines. So we're trying to say that JKL is congruent to MLK. So these two angles would be congruent. So if we think about, let's just try to extend JK and LM, just so we can kind of see the relationship between the parallel lines cut by the transversals here. And if I turn my head to the side, I can see, here's a transversal line, here's my parallel lines, and I see that JKL and MLK are alternate interior angles. So I'm going to use the alternate interior angle theorem to justify that these angles are congruent. Next, it says we're going to prove that angle JLK, I'll use a different color for this one. Angle JLK is congruent to angle MKL right here. So I see that these two are congruent, and we can also prove that these angles are congruent using that same alternate interior angle theorem. If two parallel lines are intersected by a transversal, then alternate interior angles are congruent. Next, it looks like we're proving that segment KL is congruent to segment LK. So in the diagram here, we can see, I use a different color again, we can see that KL and LK, they are the same segment. These triangles share the same side, which means that it's congruent. The same segment is congruent to itself. And we're going to use the very popular reflexive property of congruence to justify that. So reflexive. You'll see this pop up in a lot of proofs when you're proving triangles are congruent. Reflexive property of congruence. So if we take a closer look at our diagram, I'm seeing one pair, two pairs of congruent angles, and an included side, meaning the side is sitting in between these congruent pairs of angles. So our last step, triangle JKL is congruent to triangle MLK because of angle, side, angle. There we go. For more proofs and practice with angle, side, angle congruence, try out problems 1 and 3. Now let's move on to angle, angle, side congruence. Angle, angle, side congruence happens if, if two angles and a non-included side of one triangle, two angles and a non-included side, meaning that the side is not in between the two angles. That information in one triangle corresponds to and is congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. So first, let's start with our first angles, angle A and angle D. So if angle A is congruent to angle D, then let's use our next angle adjacent to that. Angle B and angle E have to be congruent here. And our side, BC, should be congruent to EF. So if all of the information is true, or if any combination of two adjacent angles and a non-included side are congruent to each other, then we can prove that triangle ABC is congruent to triangle DEF. So let's try out a proof with this one. All right, so for this proof, it's a little bit longer and we actually have to come up with the statements ourselves. So in this proof, we are given angle ABC is congruent to angle CED. I'm going to label that right now. ABC is congruent to CED. Cool. Segment AB is parallel to segment CE. AB is parallel to CE. Got it? And C is the midpoint of AD. C is the midpoint of segment AD, the entire length of these two triangles. All right, so I want to start out with some given information. I've got three things that I can use here. Let's just start with the angles. I know that angle ABC is congruent to angle CED. and the reason it's given. And let's just go ahead and write out the rest. AB is parallel to CE, also given. And C is the midpoint. C is the midpoint of segment AD. So what's happened so far, just to stop, pause, reflect, is we have proven, or we're given, that one pair of angles is congruent. We're going to need some extra information about other sides and angles here. So first, what I want to use is the information about C being the midpoint of AD. C is the midpoint of AD, and we know that midpoints cut segments in half. They're the middle point of the segment. So if that's true, then we can prove that segment AC is congruent to segment CD. AC is congruent to segment CD. And that's true because it's the definition of a midpoint. So we have one angle and one side. We're going to need some combination of angles or sides to continue to prove the triangles are congruent. So the last given information we have is AB is parallel to CE. So we're going to use some of that parallel lines cut by a transversal stuff again. So I'm just going to extend my parallel line so you can kind of visualize what's happening here. So when I look at these parallel lines, and BC would be acting as the transversal here, or we could even say AC is a transversal. I'm seeing that, let's actually just highlight AD here for a second. I'm seeing that if my parallel lines are cut by segment AD, that angle A and angle C are corresponding angles, meaning they line up in the same spot across the parallel lines. So, because of that, we can say that angle A, or let's be more formal about it, angle BAC is congruent to angle ECD. And that's true because of the corresponding angles postulate. Corresponding angles postulate. And I know this one is a bit of a throwback, but all of these parallel line theorems and postulates are going to be coming back. So due to the corresponding angles postulate, angle BAC is congruent to angle ECD. So now what we have is we have an angle, and then a non-included side. So if we just look counterclockwise around the triangle, angle, angle, side, we can prove that triangle ABD is congruent to triangle CBD using angle, angle, side. And there you go. For additional practice with angle, angle, side theorems, try out 4, 6, and 7. So that is it for our lesson. Make sure that you try out additional practice problems, check your answers with mine, and ask for support if you need it. Thank you so much for watching and have a great day.